Planet Earth, the only one that we have. Yet, our unsustainable living habits are threatening its future. The Open University of Israel, as part of the European research community, is conducting multidisciplinary research in order to help find solutions to this global challenge.
My research focuses on ways to reduce our economy's reliance on primary materials and on the subsequent changes needed in current production and consumption patterns aimed at mitigating environmental degradation.
The growing number of cars affects air pollution, and this needs to be addressed.
I use algorithms to propose a new driving system that takes into account not only driving times, but driver personality and important elements like congestion, pollution, and driving quality.
By absorbing almost half of the carbon dioxide emitted from fossil fuel burning, the ocean plays a crucial role in mitigating global warming.
My research focuses on the reactions and processes that govern the oceanic cycles of elements, particularly those that govern the oceanic carbon cycle, which affects the ocean's ability to keep on absorbing atmospheric carbon dioxide. I also study the feasibility of enhanced limestone dissolution as a means of reducing carbon dioxide emissions from power plants.
The environmental crisis is resulting in unpredictable, dangerous climate conditions. Therefore, we must understand atmospheric circulation properties.
My research aims to advance the theory on which climate models are based, to improve them and to obtain more reliable regional climate predictions. These predictions can be useful for climate adaptation and for the assessment of possible risks and impacts of climate change.
We are searching for new and sustainable solutions to produce materials and processes that can protect and even save the planet.
We synthesize halite-containing organic compounds, also known as organohalides. They are prepared from alcohols as sustainable neutral resource. The synthesis includes recyclable halogen sources and thiourea as catalysts. This process allows us to produce organochlorides and bromides, which are useful intermediates for preparing value-added compounds on an industrial scale. We also develop chemical processes that use alternative energy sources to operate dormant organometallic catalysts for potentially practical application in the industry, thus making their catalytic activity tunable.
Production of sustainable energy and materials is the future. But without understanding the chemical processes that lead to the creation of nanomaterials, our efforts will be in vain.
My research tackles fundamental problems related to high-temperature synthesis of organic nanomaterials, which are used in sensing, catalysis, and environmental cleanup. We use state-of-the-art optical and mass spectrometric methods to pave the way for predictive model-based synthesis process of environmentally important materials. Understanding the metal chemistry in high-temperature reactive environments helps in the development of green steel production, metal-enabled zero-carbon footprint energy cycle.
How do you create an impact? Social media plays a central role, but can Instagram truly see the climate crisis?
When we consume information from social networks, our worldview is shaped by the information we're exposed to. What does the climate crisis look like on Instagram? The truth is, it almost doesn't exist. Our research shows that the capitalist logic of Instagram prioritizes artificial and beautified representations of nature, while the representations of the climate crisis are pushed to the margins.
There is still much to be done. We look forward to continuing our collaborations and contributions as we work towards a healthier and cleaner future, for our sake and for future generations.